starting of the bioassay practicals, we required some requirements. So here is a setup of all requirements that we need during the bioassay practicals. So first of all, there is a need of chymograph paper. So this is the waxy paper. So one part is vaccinated and second one is the normal. Then second is the hand gloves. Third one is the clay for load adjustment. Then mask, Dettol as a disinfectant, curve needle to attach the thread to the tissue. Then there will be insulin syringe, eitherly or your tuberculosis syringe to measurement of 1 ml of solution or dose. Then forceps, thread, scissors. Here we can use any type of scissors. Then artery forceps to hold the tissue. Then the black sketch pen. So here we are attaching the black sketch pen directly to the frontal writing lever. So this is the one of the lever that we are going to use during the bioassays. Here is the normal lever, and here we can see there is an attachment of these sketch pen to the tip of lever. Again there is attachment of load with the help of clay. Then this is the aerator tube. So aerator tube is used to provide the aeration to that tissue. So here we can see there is a demo attachment of this tissue part to this aerator tube. Then there is a one clamp to give the aeration rate of 1 bubble per second to that tissue. Then there is a petri dish to attachment of this tissue part with the help of PSS. Then there is a beaker. Again, when we go for the assembly setup, here is the Sherrington rotating drum, then the organ bar, and to maintain the temperature of organ bar, here is a one digital temperature controller, and the last one to provide the aeration, there is a aerator, and these are the tubes attached to that aerator. DRC practical of acetylcholine. What is in by DRC? DRC is dose response curve. Okay. So here for the measurement of bioassay of any drug response, we have to take the bioassay of that particular drug on a tissue. So here we are using the various types of tissue. First there will be the rectus part of your frog. Okay. Second will be the ileum part of rat or chicken ileum. Okay. And third will be the hard part or the goat trachea. So likewise in the lab mode we are requiring only the goat trachea, or we are using the goat trachea. Second is chicken ileum or rat ileum. Okay. Again when we have to perform the hard response, at that time we have to set assembly of ligand drop assembly. Here we are using the Sherrington rotating drum, that is also known as the student chymograph assembly. So first of all we will see what are the requirements for the bioassay. So this is the student rotating drum. It is also known as chymograph drum or chymograph drum. Okay. Here it is in digital mode. Digital Sherrington recording drum from the Orchid company. Again there is a one organ bath. Okay, so what is the organ bath, or you can simply say the water bath. Okay, here we are maintaining the temperature of that tissue by using the water. Okay, so here we will see here is one organ tube. Okay, second the organ bath, then the temperature controller, that is a digital temperature controller. Okay, so as we know that the normal temperature for the tissue is in human body. What is the normal temperature? 37 degrees Celsius. So here we also maintain the 37 degrees Celsius as a temperature. So it is a totally automated machine, no requirement for the setup of temperature. Okay. Second, aerator. Aerator for which purpose? To provide the oxygen supply to that tissue. Okay. Again here we will see one lever is there. What is that lever? It is known as frontal writing lever. From the front side it is recording the graph of that tissue response. Okay. Then there are some holders. Okay. So here the aerator tube is there. So the short part, after attachment of the thread to the tissue part, we have to attach the smaller part to this lower side of the aerator, and to the longitudinal way there will be the second thread and parallel to this aerator. So see, likewise we have to assemble this tissue on this organ tube. So we have to put it here. With the help of this holder, we have to hold the aerator tube. Okay. And simply we have to attach it. It should not be very tight or very loose, and simply the lever should be balanced. So here you can see the aerator part is there. Aerator should be attached with this holding tube. Likewise we have to assemble all the assembly. Okay. Now where to put this rotating, you can see there will be a just simple touch to this lever and to that chymograph paper. Okay. So simply whenever there will be the rotation of this drum, there will be a whatever response of the tissue, it will get recorded on this drum. Okay. Next to that requirement, that is a chymograph paper. Okay. The one part of this chymograph paper is smooth and waxy. So the sliding of this needle, it is quite easily. That's why there will be the smooth graph of that response of particular tissue. So the smooth part should be on the upper side of that surface, and whatever the rough part is, it is for attachment to that drum. Okay. Now we will turn on these machines. So you can see the temperature regulator is now on. Okay. So there will be the temperature regulation with the help of this regulator. Then again the Sheraton rotating drum. So here we can see there is one display because of this automated machine. We have to adjust some manual settings. What are that settings? Firstly, buzzer on mode will be there to have some response or indications that now the contact time is over, the baseline is over. Okay. So we have to select there are two modes. One is the selective modes, in that CRC mode and normal mode. Normal means you can take many response. In CRC, up to the saturation level, the normal gradual increase in the dose will be have. So what is that? First, so beep interval, you can select the buzzer mode on, then CRC mode, okay. Then there are some automatic isolated organ bath settings. What are that? Tube fill, aerator, tube drain. So whenever you want to drain these tube or the PSS after each contact time to wash, you have to just on. So you will see there will be the decrease in the level of PSS from this tube. Again we have to fill it with the PSS. Okay. At that time you have to just turn off. Okay. After each dosing you have to give 3 washing of that PSS. Should be always on. So there will be the providation of oxygen supply to that tissue. Then there is again tube mode. What is the tube mode? Whenever you want to fill this tube, at that time you have to turn on this knob. And after all the experiment is done, at the back part of this drum, there will be one knob to drain the water from this organ bath. Now you can see there is the removing phase of water from this organ bath. You have to on after completion of the experiment only. Okay. So this is like a whole assembly setup of your organ bath or bioassay. Again, one missing is there. So this is your stock solution of any drug. It might be ACH, it might be histamine, it might be agonist, antagonist. Okay. So likewise we have to prepare a stock solution with the help of this. To balance this workload of this lever, we have to attach one more load at the front side. So whenever there will be the washing, at that time you have to just pull this load at the downside. Okay. So there will be no any disturbance in the graph. This is the one benefit. Second benefit is there will be some minor stretching to your tissue also. Okay. So 30 minutes that is the stretching time for your tissue. So that's why there will be the stabilization of that tissue, and you can easily have that response of drug. Okay, of that particular drug. So whenever there will be the washing, the load will be at the downside. Okay, after washing and before starting of the baseline, you have to put this load on the top of. So again, stabilization process, or you can see that there will be the equal load balance of that lever. Okay, now we will see how to run this drum. Okay, so there is a command run or not. We have to press OK. So you can see there will be baseline running. So first there will be baseline for the correction purpose. You can say you will have a 0 reading. Okay, now whatever the response will be there afterward, you can count from that 0. That there will be running of baseline. Okay, so whenever there will be the completion of that baseline, the drum will give an indication that now baseline is over. Now you have to inject whatever drug is there. So simply for the demo purpose we will take. Now we have to inject the whatever drug is near to that tissue. Okay, and again we have to press the button to start the contact time. Means now in this period the drug is in the contact with your tissue. Now there will be the increase in the graph because of the receptor binding to that tissue. And suppose example, if the drug is ACH will get bind to that muscarinic receptor, and that's why there will be the contraction of smooth muscle. So again, whenever there will be the contraction of smooth muscle, the graph will get elevated from the baseline and we will get the response of that drug. Okay. Again, we have to wait for that completion of that particular contact time. And the contact time is now over. It means the total response is now completed. Now we have to drain whatever the drug is in the tube of, or whatever the drug is present inside the organ tube. So that's why we have to drain the tube. So here you can see there is decreasing level of the PSS from the organ tube, and there is a drainage of that whatever PSS that we have used. Okay. Again, we have to fill the tube with the PSS. Okay. So this is the second washing. Again we have to drain it. So you can see here the tube is going to drain. So likewise we have to give the 3 washing to each step. Okay. Again we have to start the baseline. So here you can see the baseline is now for the second dose. Okay. Again we have to give the injection after starting of that contact time, and likewise gradually we have to increase the dose and we have to take the response of each dose.